Welcome to a lesson with Dr. Powell. Let's talk about how we can find the distance of a point from a plane. Well, what if we were to take a point over here, just any old point on the plane, draw a line here, or a vector kind of from here to here, and let's think about, and in particular, let's think about a vector that's orthogonal to the plane, or kind of a direction that's orthogonal to the plane, up and down. Isn't the distance simply the projection of this vector, no matter what it is, onto that line? That's all that is. Now, so for instance, what if we had a point like 1, 5, and 7? I'll write it as a vector, that's fine. So that's your point. So maybe that's the point right there. Maybe you have a plane. Maybe the plane is something like 2x minus 3y plus z is equal to 7. And you want to find the distance between this point and this plane. Well, look, we already have, by looking at coefficients, the orthogonal direction to the plane, or a vector that's orthogonal, namely 2, -3, 1. Now this vector is defined coordinate wise as something coming from the origin, but I can shift it over here, so just to view it here, to have a direction up and down. So take this as our orthogonal direction. Next, we need this vector here from any point in the plane to here. So we just need to find any arbitrary point in the plane at all, and we're set to go. So to do that, it's pretty easy just to take one like this, where we just maybe set 2 coordinates equal to 0, like x and y, and then find out what the other one should be. Well, apparently if those are 0, z would be 7. So 0, 0, 7 is a point on the plane. So what we're interested in to know is, what is this vector right here? That vector is simply going to be the difference between this guy and that guy. So we have 1 minus 0, 5 minus 0, and 7 minus 7, which is 0. Okay, so we have 1, 5, 0 is this vector right here. And we're interested to know, how does this project onto this direction? So projection is the exact same as dot product if what we're projecting onto is a unit vector. We're projecting onto this one, but it's not a unit vector. But to make it a unit vector is not too bad. You just multiply it by 1 over its length. And its length, by the Pythagorean theorem for 3 dimensions, we have 2 squared plus 3 squared. So -3 quantity squared, which is just 3 squared. So 2 squared plus 3 squared plus 1 squared, which is 4 plus 9 plus 1, which is 14. Take a square root. So you get the square root of 14. So we want to project this. So we're projecting this onto this direction, and which is the same as dot product if what we're projecting onto is a unit, and we just made it a unit here. We can keep this scalar multiple off to the side as we do our computation and put it in later. So we just take a dot product, we get 2, -15, 0. So we won't put that in, and multiply it by 1 over square root of 14, which would be -13 over square root of 14. Notice the negative, that's because maybe our v was facing an opposite direction from where we were going. So the projection is going to be maybe in the opposite side, but it's still on the line, which means absolute value is fine. Take the absolute value of that, and we're done. That is the distance from the point to the plane right there. Thanks for watching.